right. We're just going to have whatever review we need to have. So the idea is that you have spent some time looking at stuff and you have some questions. Let me turn back to the papers that I have for you, which isn't very many. Some of you just turned some.
As long as we can. We need 9B, 10, A, B, C, D, 11, all of those.
All right, so let me get attendance in, and then I'm ready for questions. You're just gonna ask me.
This is short. Do you know why we have math tomorrow?
Huh?
Do you know why we have math tomorrow?
It isn't mass. It's the
Black
Black History Month. Black Student Union, Black History Month Assembly.
You made the decision.
Do we go to core before?
Are you sitting on the
no.
floor? Or your
You're
class?
sitting with the four.
Oh, no.
You're sitting with
Do you hear
the
that?
four.
Oh my
We're
god.
going to
Wait,
core
are they doing
before
the
they separate
intramural
the
game
sitting with
tomorrow
our
or no?
group.
Oh, I won't be
Do you know if they're doing the intramural game?
Not tomorrow,
I
not the
have,
assembly,
the
no.
only person I can talk to is
That
Jet
is not
Walker.
later. The intramural game hasn't been decided yet, has it?
The playoffs are like, I think they finish tomorrow morning. Or like whoever's in like the
That's
championship.
scheduled
We're in
for
the final,
later,
by the
so
way.
I really don't know.
Thursday. That's because they're
Why is that?
wrong. Wait, no. We're playing you guys, I thought.
Oh, yeah.
That's a fun game.
In the finals?
Yeah, we made it.
We
Yeah.
lost. No,
You have
we
like
lost.
six.
We lost first round.
Seahawks.
Like 45.
I thought that's what you told me.
No, it was like 45-15.
Yeah, no, it was don't count our points.
Yeah. That's like half our points that I counted.
Yeah, exactly.
Time is absent.
What was your guys' final score?
It was the first game.
It's oh, I forgot to play like.
They never play games.
I am ready.
No, they
It was
actually
like,
they were.
we only lost, well, no, we did.
All right, tell me what am I doing
Against you little 14-year-old.
on
The review,
that regular review sheet?
worksheet B,
Number
it's the very last
20.
question on the last page.
The very last question on the very last page. Okay, now remember, all this is video. So, you are allowed to, of course, watch the videos when you are confused. All right, now I want that to equal to, right, this is problem 29, have I already done this? I know I did it with another class. I don't think I did it. Okay, so I'm setting my equation equal to 2. I'm solving between 0 and 2 pi, so all x values between 0 and 2 pi. Okay? So, what am I going to do? I would subtract, so 2.3 cosecant equals negative 3.1, whoops, 3.1. And then cosecant equals, thank you, equals negative 31 over 23. I got rid of the decimals, you don't have to. We're obviously going to be going to our calculator. So you can leave it with the decimals if you wish. All right. Now, I do not work very well in cosecant, so I'm going to think of this as the sine equals 23 over 31 negative. How does that seem logical to you? A couple of reasons. First of all, I don't think in cosecant, but more importantly, there's no cosecant button on my calculator. So if I'm going to go to my calculator, I want to have a button to press, right? So I'm going to change that into the reciprocal function. Okay? Now, I'm going to stop for a second, and I want to just pretend that it said sine x equals negative 23 over 31. All right, so in other words, forget all this for a minute. The sign of something is negative. Where does that happen? That the sign is negative. That happens in quadrants 3 and 4. Now, I do not know, this isn't a pi over 6 or one of those, I have no idea, but my calculator does. So I am going to go to my calculator and do inverse sine 23/31. Now, you're thinking, wait, you forgot the negative, Mrs. Ford. Actually, I didn't. Didn't I account for the negative when I do this picture? So what I am looking for is my reference angle, which is 0.836. My calculator will give me the reference angle. It's up to me to put it in the right place. Now, is 0.836 an answer? We're solving this question right here. Is 0.836 an answer? No. The answer has to be this angle, which would be what? Pi plus. So I'll just turn my calculator on and hit plus pi. So this angle, this black one, is 3.978. And then what's the other one gonna be? That will be the one all the way around here in quadrant 4. What will that one be? 2 pi minus? And I got for that one I got 5.447. Is that what you got?
Yes.
Okay, now, these are the angles that if you take their sign, you get that number. Agreed? But that angle wasn't called x. That angle was called 0.4x minus 2. So 0.4x minus 2 has to equal 3.978. Or it has to equal 5.447. Right? So what's x? That's my job. My job is to find x. I don't know if I did that right. I got 14.945. And 18.618. What do you think about that? Do those look like what you got? Neither one of those work. That makes me a little bit uneasy because that's a solvable problem. I don't know how many answers there are, but that's a solvable problem. So I'm gonna back up a minute. Why don't these work? They're too high, right? So these were the angles that I got. But by the time I added the 2 and then divided by a 0.4, which is like multiplying, this is 4 tenths. So this is like multiplying by 10/4. And that just made it get too big. Are there any smaller versions of those angles? So here's what I mean. Remember, when you had, let's say you had 11 pi over 6 is on your calculator, or on your unit circle, I mean. Another way of describing that would be negative pi over 6. Wouldn't that be the same angle? But it'd be a lot smaller. Could we find smaller versions of these angles? Of course we can. How do you find other versions of your angle? you add or subtract 2 pi. Now, I surely don't want to add because these are too big. But would you agree?
Would you not use those?
No, I don't use these. I use these. Because these are the ones that go right here. The sign of that angle. This x is not this x. So I want this angle right here. So I'm gonna, instead of using the 3.9 and the 5.4, I'm gonna use negative 2.305 and negative 0.836. Now, before we go any further, I want everyone to be comfortable with this, because this is a little bit of shenanigans here, but it's what we have to do to get an answer when we're doing this kind of stuff. So, on your calculator, would you just pick either one of those and type in, find the sign of it? So sine of that, I've got this one on my calculator, so I'll do sine of that. And then do negative 23 over 31 and see if they match. Yes, they do. The sine of these angles is negative 23/31 because these angles are just different versions of these. So now I'm going to go back and I'm going to set 0.4x minus 2 equal to those two numbers. And hopefully I get something out of that because I know this problem is going to have an answer. It's got to have an answer. So what happens? This one isn't going to work. Why isn't that one going to work? It's going to be negative. Remember. Or what about this one? 2.91. Is that one in my space? Yeah, so there we go. It's a tricky, hard problem, guys. It's tricky. But you know what? We want to get a 5, so we got to do hard stuff to get ready for a 5. We got to do it. All right. What else? Yes, it's a lot.
For the other ones that we did earlier, that like one of them didn't work, would you have to do the same thing? Or
You could go back and check to see. I was alarmed here because there were no answers. I'm not alarmed by one answer, but you can always go back and see. Always. All right, who else has a question?
Over 3.12, homework question 7.
7 on the 3.12 homework. Question 7. All right, so question 7 looks like a lot, but compared to the thing I'm erasing, it is nothing. It is an easy one. It looks like a lot, so it psychs you out, but it's really easy. Here's what I mean. First of all, my job is to find the sign of alpha minus beta. So let's just stop right there. What is the formula for the sign of alpha minus beta? Sine alpha. Cosine beta.
It's going at me.
Minus cosine beta
No,
sine.
cosine alpha, sine beta. Okay, there it is. That's your formula. All right? In order to use this formula, whether you're doing the sine of 5 pi over 12, we use that formula, or anything, you need to find these 4 numbers. Okay? So what do I know? both angles, alpha and beta, are in quadrant what? 3. They're between pi and 3 pi over 2, so they are in quadrant 3. The cosine of alpha is -5/13. Cosine is adjacent over hypotenuse, or x over r. If you envision the circle, this is the radius. This is x. Doing your Pythagorean theorem, you can find that side. It's going to be -12. 169 minus 25. Pythagorean theorem. What do I know about beta? Well, beta has a sine of -2/3. So again, y over r, opposite over hypotenuse, however you want to think about it. So this side is going to be -√5. Pythagorean theorem. Give me 2 sides of a right triangle. I can tell you the third. Oh my gosh, speaking of that, I was helping a kid the other day, not one of my own students, thank God, he'd be dead, but someone else's student. He used the Pythagorean theorem on the angles. Doesn't. But it does on the sides, and we got it done. So now I'm ready to go. Sine of alpha is -12/13. Cosine of beta is -√5/3. Cosine of cosine of alpha is -5/13. And sine of beta is -2/3. Just like when we did these with our pi over 12 angles, we have a common denominator. The common denominator is 39. 13 times 3. I'm not going to be able to combine the top, but I can simplify it. This will be 12√5 minus, because these are going to cancel, 10. And there's your answer. Okay? So that was really an easy problem. It just looked really hard. Looked really hard. All right, what else have we got? That same homework, number 6. I'm actually going to be doing something very similar, but this is a secant. I don't do secant, so I'm going to think of it as a cosine.
For that last problem, can you also, like instead of doing the Pythagorean theorem, can you just do like the sine squared plus the cosine squared equals 1?
Yes! Yes, that's a Pythagorean identity. Absolutely you can. Beautiful, Graham. Beautiful. You can always use that. Sine squared plus cosine squared is always going to be 1. Now, you got to do the same thing we did with the Pythagorean theorem, though. You got to put in a plus or minus and figure out which one it is. But yeah, yep. Okay, so I'm doing cosine 13 pi over 12. Pi over 12 is not one of my special angles. Remember, we have pi over 6, pi over 4, and pi over 3. I'm only going to do 2 quadrants here, so I think that'll do that. I'm going to make these 12. So this is 2 12s, 3 12s, 4 12s. This will be 8 12s, 9 12s, and 10 12s. Now, somewhere with those numbers, are you okay, honey? Somewhere in here, you should be able to find a couple of numbers that either add or subtract to give you 13 12ths. All right, so find a couple. So what am I going to add or subtract?
Oh, look, literally what I said on this one.
So
too.
these two?
So,
So that would be 5 pi over 6
I think I did this better. I was just trying to finish it.
and pi over 4. How is that with everybody? Are there other things you could do besides those two? Yeah, you could do 9 and 4. So you could do 3 pi over 4 and pi over 3. If you use more angles, there are lots of other ways we can do it too. But you need to find two, just find two, that add or subtract to 13/12. That's your alpha and your beta. So what's the formula for the cosine of alpha plus beta? Cosine alpha, cosine beta, minus sine alpha, sine beta. Okay? Now what do? What we did on that one, you start plugging in numbers. The pi over 4s, I use them all the time in every problem, so we know those are root 2 over 2. The others you might have to think about, I don't know. Pi over 6. Pi over 6 angle cosine is root 3 over 2. Be very careful. This is in quadrant 2, so that's going to be negative root 3 over 2. And this one's going to be positive 1/2 because the sign's positive in quadrant 2. So we have negative root 6 minus root 2 over 4. That looks familiar. We've run into that before. Right? But we're not done, because remember what we did in the very beginning? In the very beginning, what did we do? We did a cosine instead of a secant. So this is the cosine. So the secant will be the reciprocal of that. So the secant will be 4 over negative root 6 minus root 2. You gotta be careful when you don't rationalize things. Sometimes you miss a simplification, and so this one we need to simplify. We need to rationalize it. So how do I rationalize something like this? Yep, and the conjugate is negative root 6 plus root 2. Remember, with the conjugate, we only change the middle sign. Now, why is this a good deal? Well, leave the top alone for a second and tell me what happens when you FOIL out the bottom. That gives you a 6. Outside and inside are going to cancel because that's a negative root 12 and a positive root 12. And then these are going to give me a minus 2. What's 6 minus 2? Oh, there we go. So what's the answer to the problem? Negative root 6 plus root 2. Yeah. Okay? All right. What else have we got? Come on, I gave you an extra day. What?
I think Jordan's got one.
Jordan hasn't looked at this yet. Aubrey,
Can you please do 10B on the review?
10B on the big review. Remember, you got several reviews, guys. So I'm doing 10B. Okay, so 0 to 2 pi and 2 tan squared equals 3 secant. Now, it would be absolutely perfectly okay to subtract the 3 secant over. That, there is, I mean, that's good. That's a logical idea. This is a quadratic equation. I gotta have it equal to 0. This is a good thing. But you have a problem now because you can't solve that. You can't factor it because you don't have any like terms. And you can't do the quadratic formula because this is like having an A and a B. You got two different variables. You have tangents and you have secants. So find your way out of this mess. What are you gonna do? It's right there, it's in front of you. You know what to do. When I see, and when you see, a tangent and a secant in the same problem, you gotta stop and think, okay, I know that's big, there's something. What is the identity that ties tangents and secants? 1 plus tan squared is secant squared. Now, that is not squared. So that identity is not going to help you with this. But what's tangent squared? What can I plug in for tangent squared? Well, let's not introduce more variables. Let's go back to this. Secant squared minus 1. Now, guys, this is okay, because now I have one variable, secant. So 2 secant squared minus 2 minus 3 secant. Put it in the right order, 2 secant squared minus 3 secant minus 2. Do you see the difference between this quadratic equation and this one that we have here? You can't do anything with that. So you have to fix it. You did. All right, so now what? Now what can I do? Now I can factor. You cannot take a 2 out. There's no 2 here. So when we factor, we're gonna have a 2 secant and a secant. And minus 2 plus 1, does that work? I know it's the end of a long day. This is a big deal though. Let's make sure we're paying attention. Am I factored correctly? All right, so what does that say? That says secant equals negative 1/2. For secant equals 2. You know what I'm gonna do? You don't have to do it. You know what I'm gonna do though? I'm gonna change that into cosine equals negative 2 over 1. And cosine equals 1/2. And I'm gonna cross this one out because what do I know about sines and cosines? Never bigger than 1. Extraneous root, no, that doesn't even come in here. Where is the cosine 1/2? Here or here, right? Pi over 3 and 5 pi over 3. Yep, those are your answers to the question. These Pythagorean identities, there's 3 of them, remember, are used a lot to change something squared into something else. Okay? All right, what else?
9B.
On the same paper, 9B. Says find the secant pi over 2 minus theta. I'm just simplifying. The secant of pi over 2 minus theta. All right, so I'm going to do the same thing I did a minute ago for 2 reasons. Number 1, I don't like secants. And number 2, that's an alpha minus beta. And the only alpha minus beta formulas I have are for sine and cosine. So I'm going to change this into a cosine. Now, I have to remember I did that because in the end I have to change it back to a secant. So I'm writing it as a cosine. Now I'm gonna do my formula. This is alpha minus beta. So cosine of the first, cosine of the second, plus sine of the first, sine of the second. Is that all right with everybody? Now, what's the cosine of pi over 2? 0. So this is 0, this is like gone, right? 0 times cosine, that's just gonna be 0. What's the sine of pi over 2? 1. So this is just sine. So the cosine of pi over 2 minus theta equals sine. But remember, I wanted the secant, so it's gonna be 1 over the sine, which is the cosecant. Now, this right here and this right here without that in there, those are they're kind of big ideas, not something you need to memorize, but I want you to think about this for a second. Pi over 2 is how many degrees? Pi over 2 radians is how many degrees? 90. So I want you to think about this angle and this angle, okay? So if theta is 40 degrees, let's say, then 90 minus theta would be 50 degrees, right? If theta is 70 degrees, then 90 minus theta would be 20 degrees and so on. So Mrs. Ford, what are we doing this for? Because I want you to understand that this angle and this angle are complementary. What does that mean? They add up to 90. These are complementary angles. When I say the word cosine, that CO stands for complementary. Sine and cosine are complementary functions. The sine of 50 is the same as the cosine of 40. Secant and cosecant, complementary, are complementary functions. So kids always say, how come the reciprocals, how come the reciprocal of the sine isn't the cosine? Because the doesn't have anything to do with reciprocals, the has to do with complementary. So tangent, cotangent, you automatically know whatever the tangent of 32 is, I don't know what that is, but it's the same as the cotangent of 58 because of that complementary, that relationship. Okay, that's neither here nor there. The answer to the problem is cosecant, but now you know why it's called cosecant. All right, what else have we got? Oh my guys.
I do 10C to calculate a question.
All right, so which one am I doing? 10C? 10C? All right, so I'm using a calculator. I'm solving 8 sine squared plus 6 sine plus 1 equals 0. And I'm 0 to 2 pi. Well, I wonder why I need a calculator. Do you have any thoughts on that? Let's just start doing the problem and see what happens. Okay. What did I think it's factorable. Would you say it's factorable? How does this one factor? I think it's factorable. I think it factors as 4 sine, 2 sine, plus 1, doesn't that factor? Here's why you need a calculator. What does this say? Sine x equals negative 1/4? Okay, that's not, we don't know that one. This one we could do. This says sine x equals negative 1/2. You don't need a calculator for that one. What angles have a sine of negative 1/2? Well, they're down here, and it's pi over 6, but they're down here, so 7 pi over 6 and 11 pi over 6. So those I don't need a calculator for. This one I do. The angles are going to be in the same place. They're going to be in quadrants 3 and 4. Would you agree? And I just need to find out what that angle is. So I'll inverse sine 1/4, and I got 0.253. Now, I gotta find my answers though. Remember, the calculator only gives you the reference angle. It doesn't give you the answer. So how are you gonna get your answers? That one will be pi plus. So you'll just take pi plus 0.253. And then how will you find this one over here? 2 pi minus 0.253. So the only reason you need a calculator is because it's not a special angle. If it's not pi over 3, pi over 6, pi over 2, pi over 4, you're going to need a calculator. Or pi over 12, so you can do pi over 12 now. All 4 of those 2, and then whatever you got here will be your answers. Because your problem is x, you're solving for x. Okay, I found one here, just on one of these other review sheets. Remember, you've got review material in your notes. You have another review thing that I gave you. You have lots that you could be practicing. So let's look at this one. So somebody has figured out that this equation gives us the height of a Ferris wheel after t minutes. So this is minutes, and this is height. And here's the question. What is the maximum height? Just write down the problem, guys. You don't need to be certain. If you do that, it'll take forever. I'm coming up with questions because you did. Here we go. Here's the equation that gives the height of the Ferris wheel right. Question is, what is the maximum height? What? I can't hear. 7. 7. And this is a doll Ferris wheel, so the height's actually in inches. So it'd be 7 inches. This is Barbie's burden problem, Barbie's Ferris wheel. So everybody okay with 7 being the maximum? All right, here's the next question. How long does it take Barbie to get around? How long does it take Barbie to get around? What? Half a minute? 2 minutes? How could we tell? How could we figure it out? Isn't that a revolution, a period? So how do I find period? 2 pi divided by pi. So how long does it take her? 2 minutes. That's the period. That's 1 revolution. Now be careful. It wouldn't happen in a problem like this. But if that were a tangent, your period isn't 2 pi divided by this number, it is pi divided by that number. So remember that your period is pi for a regular tangent. All right, I'm going to keep finding questions unless you can find one. Can you find one? Oh, yep. Addison?
Can you do like this worksheet, the D?
You want the letters on it?
Yeah,
Mm-hmm.
D.
The one with the D? Which of the following expressions is equivalent to 4? So 3 plus secant squared minus tangent squared. 2 sine squared plus 2 cosine squared. And 5 minus cotangent squared minus cosecant squared. Well, looking at the problem, Addison, clearly my Pythagorean identities are the key here. So I'm just gonna write them all down. See what we've got here. So I know 1 plus tangent squared is secant squared. We had that one on the board before. Graham reminded us that sine squared plus cosine squared is 1. And then 1 plus cotangent squared is cosecant squared. All right, so there are the identities I'm going to use. Now, this one stuck out to me as I was writing it down. What does that one equal? It does not equal 4, it equals 2. Because if you factor out the 2, isn't this what you have? And since that is 1, this is just 2. So that is not the one, I'm trying to get it to equal 4, right? Yeah, so that is not the one. So this is wrong. All right, what about this one? I don't know. Let's see. If I look at that top identity, what is secant squared minus tangent squared? What would secant squared minus tangent squared equal? Wouldn't that equal 1? So if this equals 1, then 3 plus 1 is 4. So that's a winner. Now there could be more, so I have to check this one too. Now, you gotta be careful here, because if you're gonna group these two together, which I'm going to use my identity, won't, right, group these two, won't that change to a plus? Won't they have to look like that? Can I get a cotangent squared and a cosecant squared added using that identity? Can I get them added? No. So that's something, but it is not 1. Would you agree with me? I don't know what it is, but it's not 1, which means this is not 4. Because if that can't be 1, that can't be 4. So therefore, that was the only answer. Does that make sense to you? All right. Good question. Who else? Was there someone else?
Can you do 11E on the calculator before?
11 says find the sine of negative 143.5 over 6. Now, first of all, I can find the sine of any pi over 6. But that's a lot of pi's over 6. That's way more than I can keep track of. So I'm gonna find the mixed number for 143/6. Oops, that's not right. So that, Aubrey, is 23 whole pies and 5/6 more. So I'm gonna think of it as the sine of negative 23 and 5/6 pi. Does that make sense to you? Now remember, a revolution is 2 pi. So this is way more than a revolution. This is like spinning. So how much of that can I just take out and forget about? 22 pi's can come out. That's 11 revolutions. Bring it out. So now I'm down to, this is the sign of -1 and 5/6, which is the sign of -11 pi over 6. Now I know the sign of pi over 6 is going to be a half. I just need to figure out, is it positive a half or negative a half? Well, where is -11/6? It's in quadrant 1. So the answer is positive 1/2. Did that make sense to you? Yeah.
Could you also multiply like the 23 by like 6 by 6 to get like however much that may be and then subtract that from the total?
Oh, yeah.
Yeah.
Yeah. Somehow you just got to shrink it down. Yep. Just remember, you can't get rid of all 23 pi. You can only get rid of evens, because 2 pi is a revolution. All right, was there someone else that had a hand up? Yep. Which one?
10D.
10D. 10D says it's another solve. Now, the good news about 10D is that everything is signs. The bad news is, this one is a 2x, and that one is an x. And it's like having an x and a y in the same problem. Can't solve it. So we're gonna have to fix that. And when we fix it, I don't know, we gotta figure out what we're gonna do. We either gotta change this into x's or that into 2x's, which is gonna be a whole lot easier. What's sine 2x? Be careful. 2 sine cosine? That's my formula for the sine of 2x. That has to be done. If you have a problem with a 2x and an x, like we had here, you gotta change the 2x. Change it. Now, what do you notice about that? You can factor it. So we have sine and then 2 cosine minus 1. Right? Now, this is an inequality. Alright, so that means there's going to be some shading involved. Since my factors are less than 0, this times this, less than 0, what do I know about them? 1's greater than, and 1 is less than? Would you agree with that? Now, what are my, like I'm going to draw my unit circle here, what are my special angles where the dots are going to go on the unit circle? Well, where is the sine 0? At my unit circle. The sine is 0, I'm putting my sine in pink. The sine is 0 here and here. Where is the cosine 1/2? Cosine is 1/2 at pi over 3 and 5 pi over 3. So here's the dividing line for where sine is 0. And here's the dividing line for where cosine is 1/2. Okay? Now, what does this one say? This one says I gotta be bigger than pink, but less than green. Okay, so bigger than pink would be all of this. This is bigger than pink. And then I have to be less than green, so that would be all of this. Would you agree with that? So what is that? What answer comes out of that? Pi over 3 to pi? Is that all right with everybody? Now, what does the other case say? Well, the other case has exactly the same angles. So I got a pink dot at 0 and pi, but this time I'm below it. I have my green dots at pi over 3 and 5 pi over 3. And this time I'm bigger than it, so I'm over here. So what's my answer? 5 pi over 3. To 2 pi. Now, I need to be careful. A couple of things. 2 pi is not included. But what isn't? What is included right there? 0. So I gotta add x equals 0 in there. Remember, 2 pi has 2 names. Right? Are we okay with that? All right, those days today.
Sorry, go to the bathroom.
No, the bell is gonna ring in 2 minutes.